Assalamualaikum and good day, student. Still at the same topic, dynamic balancing, but this is a video 3. We will focus on the analytical approach. The same problem given in video 2, we are trying to solve it using an analytical approach. So this is the imaginary blade of A and D. So this is the orientation of the at a different plane of the blade A, B, C and D. So we are still taking the plane A as a reference plane. So we need to solve the total moment equation first. So given this is the degree of B, referring to the x-axis, this is the degree of C. So this is an imaginary blade. So what we do is we need to do the solving the total moment equation first. So because of we are taking the plane A as a reference plane, so what we have here now is the only three moment that has been created by mass B, C and D. So this is the formula. So you need to know that, or it is known that the total moment is equal to 0. So we arrange back the equation, it becomes something like this. Since W is constant, so we take out W from equation to simplify the equation. So you only left out with MRL. Then by the time you want to solve the equation, so you need to break it into component moment of at x-axis and moment of at y-axis. So what we have here now is the moment of D at x-axis is equal to MRB LB cos theta B, and C is times cos theta C. So putting all the value, the known value, the mass of B, radius of B, length of B, and then the degree, and same applied to C, you will reveal this equation. So left out is the moment at x-axis of D is equal to -1. So you get the amount of 1 kgm for x-axis. So same applied to moment at y-axis. So you continue with the equation of this one, plug in all the value at B and C, and then you will reveal that the moment at y-axis for that's been created by mass D is equal to negative 0.5 kgm. So how to find the magnitude and orientation of mass D? As you know just now, the moment at x-axis created by D is 1 kgm, and at y-axis is 0.5 kgm, negative 0.5 kgm squared. So let's draw the triangle of this one. First by MRD, the moment of x at x-axis, so followed by the negative 0.5. So this is the component of D at x-axis. This is the component of y-axis, since it's downward because of negative value. So the resultant force is actually representing the amount, the magnitude of a moment of D. So magnitude of moment D. The blue line here is representing the magnitude of moment D, where the magnitude is actually you can refer to this formula. So you get the amount of 1.12 kgm squared. So since RD is equal to 1 meter and LD is equal to 3 meters, so what we have here is MD, you get 0.373 kilogram. So what about the degree over here? So you can refer to this equation. So you know that tangent alpha is equal to 0.5 over 1. So you reveal that alpha is equal to 26.5. So degree of D referring from the positive x-axis is actually 300. How much? 333.5. 360 minus by 26.5. Okay. Next one. When you already solve the magnitude or the amount of D, so then you need to solve the total force from the equation of mr omega squared. So follow the same trending. This is the imaginary mass. Okay, sin F is equal to 0. So what you do is this one, since W is constant, take out the W first. So MA, left out the MAR. By the time you want to solve, you have to consider the component of X and Y. So just plug in the value of the known value of the either M or R at individual A, individual B, C or D. So you the last one, you reveal that this is the force of A at x-axis, equal to 0.166 kgm. This is the amount of force acting at y-axis is equal to 0.334 kgm. So how to find the magnitude and orientation of mass A? Same application as what we do before this. You know that the force of A at x-axis is actually 0.166. Drawing the negative 0.334 downwards because of the negative symbol, negative value, and then the resultant, the red color is actually representing the magnitude of force, centrifugal force created by mass A. So you know that the magnitude of force A is actually 0.1, this one, and then you get the answer of 0.373 kgm. Since RA is actually 1 meter, so you know that the mass of A is actually 0.373 kilogram. Same apply when you want to seek for the alpha. So representing the cosine formula, and then you reveal that the degree of mass A referring to the x-axis is 296.5 degree. So this is the location and orientation of the mass A. So the final blade orientation is actually the same as what you did from the graphical approach. So that's it basically from the analytical approach. Thank you very much.